Hello students, in this video we will solve a numerical based on series RLC circuit. So let's read the numerical firstly. A coil of resistance 10 ohm and inductance 0.1 Henry is connected in series with a 150 microfarad capacitor across a 200 volt 50 Hz supply. Calculate impedance, current, power factor, total power consumed, voltage across coil and capacitor. So we will start solving it step by step. Now firstly, what we should understand is we should visualize the circuit that it will look like. So look at this. This is a circuit that it should look like. So there is a coil which has 10 ohm of resistance and inductance value of 0.1 Henry. So what one needs to understand over here is this is a coil where we have shown that resistor is present separately and inductor is present separately. Though effectively while drawing a circuit diagram we show resistor separately and 0.1 Henry inductor separately to take its effect into account while calculating the things. But physically they two are not separable. I mean to say these two represent only one thing, that it is a coil, and inherent resistor. Coil is usually made up of some copper wire and it is in the form of some spring like structure. So though you have wound it in the form of a spring-like structure, you cannot take away its resistance from its starting terminal to the finishing terminal. So its resistance will always come into picture to oppose the current. And to take its effect into account, usual practice is diagrammatically we show such separate existence to resistance and separate existence to inductive inductance. But ultimately what one should know is this is only one physical thing, not separable from each other. So this is a coil. The thing which I have highlighted is actually a coil which is connected in series with a capacitor of 150 microfarad. I hope at least you understood the circuit so far. Now calculating the things is very easy in this numerical. Impedance. So when we want to calculate impedance, we have to take into account opposition offered by all the quantities present in the circuit, all the components present in the circuit. The three components present in the circuit are, or in fact two components present in the circuit are coil and capacitor. So coil will offer 10 ohm of resistor, inductive reactance from this 0.1 Henry. This capacitor will offer capacitive reactance from this 150 microfarad. So total opposition or impedance will be R plus J XL minus XC, where we can substitute the values as R is equal to obviously 10, and instead of XL I can write 2 pi FL, instead of XC I can write 1 by 2 pi FC, instead of this L I substituted 0.1 Henry as it was given, instead of this C I substituted 150 microfarad, instead of frequency I substituted frequency 50 Hz. So using calculator, if I calculate it, what I get is 14.28 at an angle of 45.57 degree ohm in polar form. You could have found it out in the rectangular form as well, not a problem. Now once we know the impedance, obviously this step is done. Then to find current, this impedance will help us. How? Because dividing voltage by impedance definitely will give us current. So look at this. Current can be found out as voltage being divided by impedance. So if I substitute the values already known to us, voltage is given, it is 200 volt, and being a reference phasor we can call it as at an angle 0, and impedance was found as this value when I use calculator to do this division, what I get is 14 at an angle minus 45.57 degree ampere. So current is found out. Now to find out power factor, we know this is the power factor angle, the angle that accompanies the value of current always is the power factor angle. So power factor angle can be used with cosine function. Cos of phi is power factor, so cos of minus 45.57 degree is equal to 0.7, and as it was minus, we can write lagging as a word in the bracket. So power factor is found out. Now total power consumed. One should pay an attention to this. Total power, by the word total power consumed, what interpretation should be taken? See, whenever it is consumed or delivered or absorbed, then always these words refer to active power. Always these words refer to active power, because whenever power actually is given in the circuit, flows in the circuit, resistor is the only thing that can consume or absorb power. Inductor and capacitor actually store power or energy during charging or energizing cycle, and they give it back during the discharging or de-energizing cycle. That is why whenever somebody says power consumed, power absorbed or power delivered, we have to take into account the power that is spent on resistive part of the circuit. So, and we know the power that is spent on resistive part of the circuit is called as active power. So here total power consumed represents active power, and we have to find out active power. So we will find it out. It is very easy for us to find out active power. It is power, active power is equal to Vi cos phi. Let's substitute the values. Voltage was 200 volt. Current is found out to be 14. So substituted, and power factor is found out as 0.7. So I substituted all the values, and what I get is 1960 watt. So next thing is voltage across coil and capacitor. Now see, as I said, one must understand that this much portion is coil. So we have to find out voltage that will appear across 10 ohm and 0.1 Henry together. So this can be done by finding out impedance of 10 ohm and 0.1 Henry. So look at this. Impedance of coil will be R in the format R plus jXL, where R represents this 10 ohm and XL represents inductive reactance offered by this inductor, which can be found out as 31.42. You can do this, I hope. XL is equal to 2 pi FL by using, see here it was done, 2 pi FL. So this can be calculated on the calculator, and what you should get is 31.42. And now if this is the impedance, if we multiply this impedance with the current that is flowing in the circuit, what I get is voltage across this coil. So look at this, I into this impedance will give me the voltage across coil. So what I did is I multiplied, look at this, this was the value of I substituted, and now this was the value of R plus jXL for coil. So substituted, when I use calculator to do this multiplication, what I get is this. So voltage across coil will be 461.58 at an angle of 26.78 degree volt. But this is not yet done. We are supposed to find voltage across capacitor as well. Voltage across capacitor will be Vc into Ixc. This is equal to value of I substituted, value of Xc can be calculated from this, will come out to be 21.22 at an angle minus 90 degree. What we get is voltage across capacitor is 297.08 at an angle of minus 135.07 degree volt. So I hope this numerical was understood. The only important thing to be taken care over here is you may commit mistake while calculating voltage across coil. Somebody may think that voltage across coil is as good as finding voltage across this inductor, but that is wrong. Voltage across coil is actually to find voltage across these two components, because these two components are representing only one thing, and that is coil. So solution over here is correct. Please take care and don't commit mistake. Thank you.